Now what we're going to do is show that the statement P or not Q is equivalent to the statement if not P, then not Q, where what we have to do here is think in terms of truth tables. Because the truth table is our best way to take all of the possible options that we have for a statement and figure out if the truth values are consistent. So, what we're going to do here is, again, start out like we did with many of our other examples. Think about our components, P and Q, and we're going to take our time going through the cases here. So just bear with me while I copy down the basic stuff. Nice thing about doing these things over and over again is that hopefully you're pretty good by now at copying that first column, or the first pair of columns, depending on how you want to see it. But anyway, next I'm going to look at the negation of Q. So I'd get false, true, based on how this is set up. Then I look at the disjunction, P or not Q. Here, we just need one of these two to be true in order for the whole thing to be true. Nice thing about our disjunctions. So this is true, true, false, and then finally true. Then we're going to take our next piece, which is the negation of P, because we're going to build towards that conditional in the second part, where the negation of P will be false, false, true, and true. And now we've got kind of an awkward thing to read, because you have to look at the negation of P implying the negation of Q, which means we're going in that direction between these two columns. So here, we're reading right to left. This is false, so don't have to worry about what happens on the other side. Same thing with the second case. Again, conditionals, you get a lot of trivial cases. It's not a great deal to worry about with those. Here, though, we get the antecedent is true, subsequent is false. So that's false. And then finally, we get the nice true case where both in the conditional statement are true. And here what we can do is look at the two columns we have for P or not Q, and not P implies not Q, and see that our truth values are the same. That's what we want to look for here to show equivalence, show that two things have the same value, that they refer to the same thing, is we see that for any case that goes into their components, or any case that comes from their components for that matter, we get the same cases back. So we can say that these two are equivalent, and we notate that P or not Q is equivalent to not P implies not Q, and we notate equivalent with a 3-lined equal sign that says is equivalent to. And this is something that we've seen before, but we just haven't called it that. For example, we could say that the statement P is equivalent to the negation of P, which is something that we saw on our worksheet last week.